find an expression of ER as a basis of E rho K, it's very easier to find in the bases E, G, and K. So here's what we're going to do. Now, before I do that, let me find an expression of E theta. Okay, because I said that R is associated with theta. Therefore, ER is perpendicular to E theta. Then what does this help us with? This helps us with saying that the derivative of ER with respect to theta is equals to what? E theta. Okay, so if I have my ER, it will be very easier for me to find E theta. Okay, E theta. So now, why? Because from our drawing, we saw that from our drawing, we said that ER is perpendicular to E theta. Therefore, the derivative of ER with respect to theta is E theta. So if we have the expression of ER, you can find the expression of E theta. Then E rho, another thing that you need to note here is E rho is changes with the change of phi. So the derivative with respect to theta means that E rho is constant, because when theta changes, E rho doesn't change. Therefore, E rho is constant when you're finding the derivative with respect to theta. So going back to what we have, we're from finding that ER is equals to sine theta in the direction of E rho plus cos theta in the direction of k. Okay, so now let's find E theta. So let's find the derivative of ER. So the derivative of ER is simple. So you apply the product rule, because the first term is a product and the second term is a product. Okay, so how do you apply the product rule? The product rule is simple. You find the derivative of sine theta with respect to theta, then keeping E rho constant, then you add. Then the second thing that you do is you keep sine theta constant, then you find the derivative of E rho with respect to theta. Okay, then even on the second term, you're also going to apply the product rule. What are you going to do? You're going to find the derivative of cos theta with respect to theta, keeping k constant, plus now you're going to keep cos theta constant. You're going to find the derivative of k with respect to theta. Okay, now here's an interesting thing to know. An interesting thing to know is that E rho, we said that E rho is not changing with theta. Therefore, the derivative of E rho with respect to theta is going to be 0. Okay, it's going to be 0. And then the derivative of k with respect to theta, k is part of the fixed base system. Therefore, basis system. Therefore, k is the derivative of k with respect to anything is 0. Therefore, when you're finding the derivative of E theta, ER to find E theta, okay, you're only going to have the derivative of sine theta with respect to theta, then keeping E rho constant, plus the derivative of cos theta with respect to theta, then keeping k constant. The other terms are constants, therefore they give us 0. So you still apply the product rule, except that you have to know which one is constant and which one is not constant in order to apply the product rule. Okay, so now E theta is going to be equal to, so now the derivative of sine theta, so if you want to know how to find derivatives, you say sine theta, negative sine theta, cos theta, negative cos theta. So when you're finding derivative, you go downwards. So for example, the derivative of sine theta will be cos theta. So here you just say cos theta E rho. Okay, and then what's the derivative of cos theta? You come here. The derivative of cos theta, you go down, negative. So it's going to be negative sine theta in the direction of k. Therefore, from ER, you found what your E theta is. Okay, so from ER, this is another important thing to find. So from ER, you find what your E theta is. Okay, so here we can safely say from what we found that ER was equal to sine theta E rho plus cos theta k. Then E theta was equal to cos theta E rho minus sine theta k. So these are the most important vectors that you need to find. And the unit vectors for the spherical coordinate systems are ER, E theta, and E phi, which means you have to know how to find expressions for ER, E theta, and E phi. So we found ER, and ER we just find that its derivative with respect to theta to find E theta. Then E phi is the same one. How did you find E phi in the polar coordinate system? The polar coordinate system, we said that E rho was equal to cos theta in the direction of E plus sine theta in the direction of G. Therefore, if you want to find E phi, because E rho is associated with E phi, you just find the derivative. You apply the same derivative pattern that I've just shown you. So a derivative of cos is going to give you negative sine theta E. Then the derivative of sine is going to give us plus cos theta in the direction of G. Of course, you're going to apply the product rule, but you're going to find that E and G are constant. So you have to know. So here you have got three expressions. You've got the expression of E rho, the expression of E phi, then you also have the expressions of ER and E theta. Now, notice that in the expression of ER, there's E rho, okay? And the expression of E phi, E theta, there's an expression of E rho. Therefore, for you to find ER, you just have to know the expression of E rho, which is here, and then you can replace, when you replace it into this one, then you're going to have your ER in Cartesian coordinate system. Let me replace and show you what I'm talking about. So we said that we found our ER to be equal to sine theta E rho plus cos theta k. Okay, k is already in the base Cartesian, so E rho. Now what is our E rho? E rho is equal to cos theta E plus sine theta G. Okay, so you can now replace it. ER, you just do a bit of algebra. So what is our E rho? E rho, you put cos theta E plus sine theta G. Okay, and then plus cos theta k. This is how you convert ER in what? In the base Cartesian. If they tell you express ER in the base Cartesian, that is as a function of E, G, and K. So you just multiply sine theta outside cos. This is cos phi. I made a mistake. E rho is always associated with phi. So don't make this mistake. So phi here, okay? So cos phi E, then plus sine theta, then sine phi G, then plus cos theta k. So this is how you find your ER. Then you can find E theta as well by replacing in your expression of E theta. You can also express, you can also replace it with um E rho. So E theta as well, E theta, we found it as cos theta E rho minus sine theta k. Okay, so we're also going to replace it with an expression of E rho. Okay, so my E theta is now going to be equal to cos theta. What's the expression of E rho? E rho is cos phi in the direction of E plus sine phi in the direction of G, okay, minus sine theta in the direction of K. Okay, so my E theta is going to be cos theta cos phi in the direction of E plus cos phi sine phi cos theta sine phi in the direction of g, then minus sine theta k. So you've expressed it as a function of in the as a function of e g k. So this is so your e theta is now in as a function of e g k. Your e rho is also as a function of e g k. So this is how you find er, e theta, e rho, and e phi in the base Cartesian. Okay, and this is how you construct everything that you need to know about the spherical coordinate system. So, for the in summary, for the Cartesian coordinate system, they use E, G, and K as base vectors. The Cartesian. Then for the cylindrical coordinate system, in my previous video, we said E rho, E phi, and Ez, which is the same as K. Okay, cylindrical. And then for the spherical coordinate system, it's ER, E theta, then E phi. So you just have to know how to express these unit vectors as a function of in the Cartesian basis system or de la base Cartesian en français. Yeah, so this is how we construct the spherical coordinate system and all the parameters that you need to know. So you construct so it uses the angle phi and another angle theta, then this is AR, then this is E theta, then E rho, E phi. Then one interesting property about vectors is that the derivative of a vector with respect to the angle theta will give us the vector perpendicular to it, which is E theta. Okay, so you have to know that ER is always associated with E theta. Then E rho is also always associated with E phi, such that the derivative, when they ask you to find the derivative of E rho with respect to the angle phi, you find E phi. The derivative with respect of ER with respect to the angle theta, it will give you E theta. Then for you to find the expression of ER, you create that rectangle that we created, identify the parts, apply trig identities, and you find the expression of ER. Then you can just find its derivative with respect to theta to find E rho. Then in an expression of ER, you find that there will be E rho. Then E rho doesn't change with theta, therefore it will be constant. Therefore, you want to apply the product rule. Instead, you find the derivative z directly. And then, yeah, basically, this is everything that you need to know about the spherical coordinate system. Then the other important thing that you need to know is how to find the OM. OM is simply found by RER. OM, the point M will be here, OM will be RER. So this is everything that you need to know in the spherical coordinate system, and thank you for watching. Subscribe for more.